بسم الله الرحمن الرحيم. أبنائي وبناتي طلاب الصف الأول الثانوي، بنكمل مع بعض حل كتاب المعاصر يونت 2 شابتر 1 موشن اند فيلوسيتي. السؤال الأول بيقول لي if the average velocity of a body during a certain time interval equals 0. Average velocity equals 0. That means what? That means displacement over time equals 0. Time will not equal 0. The displacement equal 0. So, like the object goes from A to B and return back from B to A, so the displacement equals 0. What can you deduce about the displacement of the body during this interval? The displacement equals 0. That's it. Okay, let's move to number 2. In the opposite figure, two objects A and B have moved from rest in a straight line. Which object has been faster and why? From the graph, it looks like B faster than A because, as you see, the slope for B is larger than the slope for A. And if you want to be sure, just calculate the average velocity for both. VB equals distance over time, so 500 minus 0, 500, over 100 minus 0, 100, means 5 meters per second. VA equals 500 minus 0 over 200 minus 0, it means 2.5 meters per second. So VB larger than VA because the slope of B is larger than the slope of A. Let's move to the next, number 3. The opposite graph represents the change in displacement of two objects A and B. This is A and this is B. Relative to the building with time. This is a building. Okay? Which of them is moving away from the building? As the time path, you see B come closer to the building. Right? B closer to the building. And A farther or go far from the building. So A go far away from the building. B gets closer. So we answer letter A. Which of them is moving away? A, from the building. And which is getting closer to the building? A, object B. Type. Letter B. Which of them is moving uniform? From the graph, as you see, explain your answer. Uniform A. A is moving in uniform velocity, because when you calculate the velocity, you will get the same number every time. Okay? So, which of them is uniform velocity? Object A. And which is moving with non-uniform velocity? As you see, object B. It is not a straight line and it covers unequal distance in equal amount of time. For object A, cover equal distance in equal amounts of time. For object B, cover unequal distance in equal amount of time. So we answered number 3. Number 4. A car moving in a straight route at t equals 0, the driver saw a barrier on the road. So he pressed the brakes. When that happened? At t equals 0. at t equal 0. So he pressed the brakes. The opposite graph represents the relation between the velocity of the car and the time. Describe the velocity of the car during the intervals AB and AC. So AB, as you see, the velocity here, the graph between velocity and time, take care. The velocity is constant, right? 15 meter per second. So the velocity between the points A and B is uniform, 15 meter per second. And for the B to C, as you see, the velocity is changing. So the velocity here is non-uniform. As you see, the velocity is decreasing, but decreasing uniformly. Decreasing uniformly. But the velocity itself, non-uniform. Non-uniform. Here, letter B, calculate the displacement covered by the car from t equals 0 to t equals 3.5. When you get a graph between velocity and the time and they ask you to calculate the displacement, just get the area. Let's get the area together. We can divide this area into two sides, right? The first part is like a rectangle or square. How to get the area of it? So the area equals height times base. So from 0 to 2, 2 times from 0 to 1, 15, 15, right? Plus the area of this rectangle, half equals half the base from 2 to 3.5, 3.5 minus 2 times the height is 15. Let's calculate it. Here is 30 plus half times 15. Let's see on the calculator. It equals 41.25, and the area in meter square. The area in, sorry, it is not area now, it is in meter. It is in meter. So this area equal displacement, but how it is in meter? 15, the 15 here, meter per second, times second, so second goes with second meter. And here, 3.5 minus 2, it is in second. And 15 in meter per second, right? So it is in meter per second, goes with second. So the displacement in meters. Let's move to the next. The opposite figure shows two girls trying to measure the speed of the river's water stream, the stream. The girl that stands on the first bridge drops a piece of wood. This girl that's in the water, and the girl that stands on the second bridge measure the time. This girl measure the time, and this is the wood, log of wood taken by the piece of wood to reach the second bridge. Mention the suitable tools that can be used by the girls to measure the distance. Distance, it is the distance 50 meters, so we can use meter tape, right? شريط المتر. Between the two bridges, and also time. Time, we can use stop watch, right? If the time taken by the wooden piece to cover the distance between the two bridges is 400 seconds, So now we have the time. Calculate the speed of the river. So the speed equal d over t. D is 50 meter, t is 400. So 0 goes with 0, 5 over 41 over 1 over 8 means 0.125 meter per second. This is the speed of the stream of the river. Let's go to next page, 163, 164. Number 6. The opposite displacement time graph describe the motion of a body in a straight line. This displacement and this time. Is the velocity of the body positive, negative, or zero at t equal 1? T equal 1 here, so we need to make tangent, and as you see, the slope of this tangent is positive. Right, guys? Positive. At t equals 0, 2, so here is the tangent. As you see, the slope of this tangent vanished. It means equals 0. Right? For t equals 3, the slope, as you see, is going down. So this slope is negative. So the velocity becomes negative. Let's move to number 7. Compare between the average velocity and the average speed of a man who is moving in a straight line in the direction of A. The east to cover displacement D. So the object moving this way, right? Or the man moving this way. This is 0 and this is east. As you see, here the velocity equal speed. The average velocity equal the average speed. Both are equals. So average velocity equals average speed, because the man doesn't change its direction. So the displacement is the same as distance. So both are equals. B. The man moved the east to cover the displacement D, and then he reversed his direction to cover a displacement D. So he moved to the east to cover displacement D, and after he returned to same point. So here the displacement equals 0, but the speed or the distance equal 2d. Distance equal 2d, right? So the average velocity is less than average velocity, less than average speed. You know why? Because here in velocity you need to divide displacement over time, and displacement equals 0. So always average speed larger than average velocity. For letter C, the man moves the west to cover displacement D. The man moves the west to cover displacement D. And then he reverses his direction to cover displacement D over 2. So, as you see, the displacement here equal D over 2 to the west, right? And the distance equal D plus D over 2. So 3D over 2 distance equal D over 2 plus d equal 3d over 2. But distance, this distance, sorry, displacement, let's calculate displacement, equal d over 2 in the west direction, or negative d over 2. So the average velocity also less than average speed, because to calculate the average speed you divide the 3d over 2 over time, but when you calculate average velocity you divide d over 2 over same time. So average velocity also is less than average speed. That's enough for this video. God bless all of you. كان معكم مستر إبراهيم سلطان فيزيكس اند كيمستري تيتشر. لا إله إلا أنت سبحانك إني كنت من الظالمين.